So perhaps you're finding this downsampling and upsampling and all these sampling frequencies and Nyquist frequencies too confusing. So let's try to explain it again using an example. So in our example, we will take a signal which has a sampling frequency of 32 kilohertz. We will downsample by a factor of n equals to 2. So at this point, it will have a sampling frequency of 16 kilohertz. We will take the signal, we will upsample by a factor of 2. So it goes from 16 kilohertz back to 32 kilohertz. What we need to do and observe in this process? We go from 32 kilohertz to a sampling rate of 16 kilohertz. The Nyquist theorem tells us that a signal with a sampling frequency of 16 kilohertz must be band limited to 8 kilohertz. So we need to remove all frequencies above the Nyquist frequency, in this case 8 kilohertz, from our original signal before downsampling. So we pass our signal to a low-pass frequency, low-pass filter with a cutoff frequency of 8 kilohertz. As we showed here, the cutoff frequency normalized to the Nyquist frequency at the higher sampling rate must be 1 over n. So n is equal to 2, 1 over n is 0.5. The Nyquist frequency of 32 kilohertz is 16 kilohertz. 0.5 is equal to half the Nyquist frequency. So half of 16 kilohertz is 8 kilohertz. So we take our signal, we pass it through a low-pass filter with a cutoff frequency of 8 kilohertz. So at this point we didn't change the sampling rate, but we band limited our signal to 8 kilohertz. Now we drop every second sample. So we remove every second sample. And at this point here, we have a signal with a sampling frequency of 16 kilohertz and band limited to 8 kilohertz, respecting the Nyquist theorem. Now we take the signal and we want to upsample it by 2 to go back to a sampling frequency of 32 kilohertz. So what we need to do? We take our signal and we can upsample by 2 by insert a 0 after every sample. So at this point here, we change the sampling frequency of our signal. It goes from 16 kilohertz to 32 kilohertz. But in this process, by inserting zeros after each sample, we introduced alias. And we don't want this alias. So what we need to do? We need to pass this signal to a low-pass filter. We apply a low-pass filter with a cutoff frequency of 8 kilohertz, which is 1 over n normalized to the Nyquist frequency at the higher sampling rate. So the highest sampling rate is 32 kilohertz. The Nyquist frequency is 16 kilohertz. Half of the Nyquist frequency is a cutoff frequency of 0.5 is equivalent to 8 kilohertz. So at this point, our signal has a sampling frequency of 32 kilohertz, but it has these alias components that we will remove after we apply a low-pass filter with a cutoff frequency of 8 kilohertz. So now our signal has a sampling frequency of 32 kilohertz and it's band limited to 8 kilohertz. So as we said here, we reconstructed our signal identical to the low-pass version of the downsampling size. So at this point, we had a signal with 32 kilohertz band limited to 8 kilohertz. And at this point, we have a signal with 32 kilohertz band limited to 8 kilohertz. After downsampling, we have a signal with a sampling rate of 16 kilohertz and band limited to 8 kilohertz.